Welcome to the second session, my dear students. Today we are going to discuss in the second session, that is classification of transducers. Okay, how we are going to classify the transducers and what are the various types of transducers. All these things we are going to learn in a detailed manner. Okay, wait a minute, my dear students. I am sharing the screen. Okay. How many types of transducers are there, my dear students, in the classification? Okay, the classification of transducers, as I told you, okay, it is of generally how many types? Five types. First one, on the basis of the transduction principle. Second one, primary and secondary transducers. Third one, passive and active transducers. And fourth one, analog and digital transducers. Fifth one, transducers and inverse transducers. Okay, now we are going to study one by one. Let us start with the first one, the on the basis of the transduction principle. Okay, here in all these particular classification of transducers we are going to study, okay, what are the examples also. Okay, now first one, on the basis of the transduction principle. Okay, on the basis of the transduction principle means see here, transduction principle itself, as I told you, this is the general transduction principle. Okay, as I told you, which is very important, my dear students. Okay, now listen. On the basis of the transduction principle means this is, okay, this one is the transduction principle, where we are going to transform. See here, what are the input you are going to give, okay, for this transduction principle. This transduction principle means, transduction means conversion. This is converting the output into resistive, inductive or capacitive. Means what are the input you are going to give, the output will be in the form of resistive, capacitive or inductive. That's the reason the examples of these transducers are called resistive, capacitive and inductive transducers, my dear students. This is on the basis of the transduction principle. Okay, next one is primary and secondary transducers. So in instrumentation engineering, there are certain industries, only one conversion is not needed, there is more than one conversion. Okay, that okay, we are going to use. Okay, so there we are going to use the different types of transducers. Okay, only one transducer is not enough, we are going to use more than one transducer, okay, that's the reason. Okay, these transducers are called primary and secondary transducers. I am going to explain this concept by showing one example over here. Okay, see here, I am going to explain this particular concept with respect to this one. Okay, the block diagram, that is the diagram. Okay, which one is a primary transducer and which one is a secondary transducer? Let me explain. Okay, this is the block diagram in which listen carefully here. See here, which one? This is a Bowden tube. The Bowden tube is converting this pressure into the output. Here I am going to get the output. I am going to get here itself is displacement. I'm going to get the output will be in the form of what? Displacement. I'm going to get the displacement. Okay, and this displacement is converted. This displacement is converted by these LVDT. This is LVDT into the output voltage. Means if I want to convert the pressure, this is a general pressure one. Okay, this pressure, okay, into the output voltage, I'm going to use that is two instruments. One is the Bowden tube and second one is what? LVDT. Okay, here Bowden tube is converting pressure into displacement. That's the reason this transducer is called primary transducer. And here this LVDT is converting okay, this is converting the, okay, the displacement into the output voltage, and this one is called what? Secondary transducer. Okay, that's the reason I'm going to tell you, one conversion is not enough, there is more than one conversion we are going to do. Okay, so this is that one. Okay, that's the reason I have explained here the primary and secondary transducer. Okay, what is primary transducer? Primary transducer means the first transducer, okay, which is converting the physical phenomena, that is the pressure. This physical phenomena is what? Pressure. Okay, this is pressure. Okay, or displacement. The other parameters also you can take it, pressure or displacement, which is accepted by the next stage. Next stage is what? LVDT. I have explained with respect to the example, and this one is called primary transducer. Okay, and the output of the primary transducer, okay, I am going to convert into the usable output. I'm converting into the usable output, and this one is called a secondary transducer. The best examples are Bowden tube as a primary transducer and LVDT as a secondary transducer. This is regarding the classification of second type of transducers. Okay, next, the third category, okay, the third category of the transducers are called passive and active transducers. What are passive transducers? Passive transducers means they don't require that they require some auxiliary power source. Sorry, they require some auxiliary power source. Okay, and these are not self-generating type. Okay, so they are dependent, they are passive. Okay, they require some auxiliary power source. Okay, and the best examples, as I told you, that resistive, inductive, and capacitive transducers. Okay, as I mentioned over here. Okay, mentioned over here. See here, these are the transducers require auxiliary power source. Okay, examples are resistive, inductive, and capacitive transducers. Means this is passive. It is a dependent. It definitely it requires some auxiliary power source. Okay, requires some auxiliary power source, my students. Okay, next one, active transducers. I told you that these transducers are self-generating type. Okay, these are the self-generating type of transducer. Since they develop their own voltage or currents, okay, they are going to develop their own voltage or currents. Okay, that's the reason the examples are photovoltaic cell, thermocouple, and piezoelectric crystal. Okay, generally thermocouple is used for the measurement of temperature. Piezoelectric crystal is used for the measurement of force, and photovoltaic cell is used for the measurement of the displacement. So we are going to study these concepts later. Okay, here I am going to show you the examples and what is a transducer. Okay, now you got clarity idea regarding the passive and active transducers. Now, analog and digital transducers. Okay, here if I am going to take it, this is a transducer. I am going to give certain input, and the output will be the form of continuous. Okay, continuous with respect to the time. This is analog. If I'm going to give an input, the output should be the form of discrete pulses. Then it is called a what? That is a okay. That is a digital transducer. That's the reason I have explained analog transducers. As I told you that analog transducer is this one. Okay, which convert this is the input quantity, which is a continuous function of which is a continuous function of time. This is a continuous function of the time. See, this is like this, like this. Okay, the best examples are LVDT and thermocouple. Okay, which is we are going to give input and you are going to get the output is a continuous function of time. And digital transducers. Okay, these transducers they are going to convert the input quantity in the electrical, that is output, that is in the form of pulses. That is in the form of pulses. Okay, suppose if I am going to take it here, it will be in the form of like this, pulses. So it will be the form of discrete pulses. The best examples are digital tachometers and digital resolvers. These are the examples. Okay, digital tachometers are used in the measurement of velocity, and digital resolvers are used in the measurement of displacement. Later we are going to study these things. These are the examples of analog and digital transducers. Okay, next one is transducer and inverse transducer. Okay, what is a transducer? A transducer converts a non-electrical signal into electrical signal, my dear friend. Okay, this is but inverse transducer means it is converting the electrical signal into non-electrical signal. Okay, this is the best examples of the inverse transducer means which performs. Here I shown that that concept with respect to the vice versa. Vice versa means reverse. Okay, a transducer is converting what? A transducer is converting a non-electrical signal into electrical quantity. Okay, okay, and vice versa reverse. Okay, what are the examples? These are the examples. Okay, piezoelectric crystals, analog ammeter of the voltmeter. These are the examples. I will tell you in the communication systems also. Okay, see, if I'm going to teach you the subject of the communications, this is transmitter and this is a receiver. I am speaking, this is a non-electrical signal. This transmitter is converting the non-electrical signal into electrical. Next, the electrical signal is moving to the receiver. Again, the output is non-electrical. Means Here, the transmitter consists of transducer, which is converting the non-electrical signal into electrical, and receiver consists of inverse transducer. It is converting electrical into non-electrical, original form of the signal. The best example is the communication in between the transmitter and the receiver. Okay, so in the transmitter we are using what? Transducer. In the receiver we are using inverse transducer. Okay, this is about this concept. Now, with that, I have explained about the classification of transducers, my dear students. Now, I am going for the what are the characteristics that make you to prefer the general transducers. Okay. Now, the characteristics of transducers. Generally, there are three types of characteristics. One is the input characteristics. Second one is the transfer characteristics. And third one is the output characteristics. Okay. The input characteristics. Okay. Input characteristics are pretty important over here. First one is the type of the input and operating range. Type of the input means what kind of input you are going to give for the transducer and what is the operating range. Okay, how to get a good output. Okay, the operating range also we need to know when you are going to give any input. Okay, second one I'm going to tell you itself is loading effect. Loading means when I'm going any input, how much load it is going to be that is beared by this particular transducer. We need to check when we are going to give any input to any particular transducer. Okay, now second one is that is transfer characteristics. Okay, these are very very important. Okay, the transfer characteristics means how a that is transducer is bearing those particular characteristics. First one is transfer function. Okay, the mathematical modeling. Okay, so this mathematical modeling. Okay, so how we can mathematically model the equations in transducer that I'm going to explain in the measurement of acceleration. Okay, next what kind of errors that you are going to get when any input is subjected to a transducer. And third one is that what is the response of these transducers to environmental conditions? Means suppose I'm going to use this transducer for longer periods of time under environmental conditions. So what kind of impact is there on the transducer? That we are going to study over here in the third one. This is error. Third one is the response. My dear students. Okay. Now this is the transfer. And next one is output characteristics. Okay. So when I'm going to do the input, the transducer is converting the non-electrical into electrical output. Okay. So what type of output you are going to get? What is the output impedance? And what is the useful range? Okay. So when it is giving output, the output will be in a good stable output that is going to give in a only stipulated range. The other range is not a good output. That is the unstable output. Okay. So that also we need to check it. So that's the reason here the output characteristic is type of electrical output, output impedance, and third one is useful range. These three characteristics must be considered while in the characteristics of the transducer. Characteristics of the transducer is nothing but the key learning. Okay, the behavior of the transducer. Okay, now these are the so while we are going to use transducer, we have to know that the properties of these particular transducers. Now, what are the factors that make you to use a particular transducer? Means what are the factors that are influencing in taking any particular transducer that I am going to explain in the next slide. Okay, first one is operating principle. Okay, operating principle means see transducer works. So in the measurement of acceleration, the transducer is working on one principle. Okay, similarly in the measurement of pressure, that the different transducer that is working on one principle. I will tell you all those things at that point. Okay, so those particular things I'm going to explain. Second one is sensitivity. Okay, sensitivity means what is the input that you are going to give. The transducer will give a stable output. It means the input should be given, the output will be stable. That is sensitivity. Third one is operating range. Operating range means if I'm going to take the that is a transducer, if the transducer is giving output only, I told you it is stipulated range. What is that range? We need to know. Okay. Fourth one is accuracy. Okay. Every time we have to use because the transducer is working using for a longer periods of time. We need to see the accuracy. How much accurate is the instrument? Okay. Fourth one is cross sensitivity. Every time we need to check the cross sensitivity of these transducer by taking certain reference transducers. Okay. So how much of this is accurate with that reference transducer? We need to check their sensitivities in a cross manner. Okay. Next one is errors. Okay. So what kind of errors that you are going to get internally in a transducer? So what kind of that is internal errors, that is instrumental errors, and what is the external errors like environmental errors? We need to check all the errors that are concerned with respect to the transducers. Next one is transient and frequency response. Okay, this I am going to explain in the measurement of force, so in a detailed manner. So suppose I am going to use a transducer in the measurement of force. So what is the frequency response and what is the transient response, that I am going to explain in detail over there, my dear students. Okay, these are the factors that are influencing the choice of preferring the transducer. Not only these, we are going to have the certain other factors also. Okay, the next one is the loading effects. Okay, how much load it can bear by the transducer, how much load it is gained by the transducer. Next one is environmental capability. Environmental capability means the how much see the capability of this particular instrument is there. Okay, environmentally how much means what is the impact, okay, of atmosphere on this particular transducer we are using for longer periods of time. That is that one. Next, third one is insensitive unwanted signals. And see, there are certain unwanted signals that are going to be that is going to attack to the transducer. Now, how much it is sensitive, how much it is insensitive, we need to check. Okay, that is the next one. Next one is usage and ruggedness. Usage and ruggedness means say how we are going to use this particular instrument, how much rough is there, how much delicate is there. We need to check when we are going to use for the longer periods of time. Then only you came to know. Okay. Next one is electrical aspects. Electrical aspects means if I'm going to give the input, how the output I'm going to get. Okay, how much output I'm going to get, we need to check in a proper manner. Next one is stability. Stability means say I have using this transducer, how much stability is working for a longer periods of time. That is stability. Next one is reliability. Means once how much this instrument is reliable, how many years it can be used for longer periods of time, how much this instrument is reliable, we need to check based upon the reliability. And final and the foremost is that is the static characteristics. The static characteristics means how much, okay, the characteristics are the static in nature. Okay, generally I'm going to give the input for this transducer, I need to get the 100% output, okay, at that time only. For example, I have taken. So here what happens, we need to check the accuracy in a static way. So we need to study the static characteristics. Okay, so we need to study all these particular factors when we are going to use or taking the transducer as the preferenceable one. That's the reason in instrumentation core we are going to use the transducer and the measuring of various types of quantities. That is the importance of these particular transducer. Okay, now these are the things that we have concluded. Now, in this session, we have finished, okay, about what is a, okay, transducer, what is its classification, what are the various types of transducers and their respective examples. Next, what are the characteristics of transducers, what are the factors that make you to prefer the choice of transducers we have been discussed. And finally, the conclusion itself, okay. Conclusion means this is the second session completes the total introduction part. Okay, what does the transducer means? A transducer, what is converting? A transducer is converting which one? It is converting the one form of energy into the other form. It is converting into the. So all these transducers are used now in the second, that is chapter, in various applications like measurement of acceleration. That's the reason I told you here. These transducers are used in various applications, measurement of acceleration, vibrations, shocks, temperature, next pressure, next flow, viscosity, measurement of pH. So all these, okay, we are using the different types of transducers in different applications in measuring the different quantities. Okay, so with that, we have completed our particular session with respect to the session 2 of the introduction part. Okay, in the next session, chapter 2, I'm going to explain the each and every measurement of non-electrical quantity in a detailed manner. Okay, where we are going to study each and every concept followed by the mathematical formulas and followed by the numerical model problems. Okay, like that we are going to complete the particular subject. At the end, we are going for the solving of all the gate previous problems. Okay, my dear students, thank you very much.